Hi everybody, this is Mrs. Ellsworth. What we're going to be talking about today is about light. We've talked about sound and sound is made up of waves and light is made up of waves too. They're a different kind of wave. In fact, with light, we've got a couple of different kind of waves going on. We've got electric wave, electric field wave that is going up and down in this case right here. And this at the same time, simultaneously, the same wave, so these two would be transposed upon each other. There's a magnetic field that is also going horizontally. So these two waves are here going together and that they are going in 90 degrees of one another. And here's another picture of it. Maybe this helps explain it, that they go simultaneously. So this is called an electromagnetic wave. And all light and all types of radiation comes in electromagnetic waves. Okay, so they're made up of two different fields. Okay, let me get that out here. Okay, so here is the whole electromagnetic spectrum. Okay, now there's only one small portion of this that is light. Okay, and that is this visible spectrum right in here. And that is what we call the waves of Roy G. Biv. Okay, you got red, orange, yellow, Roy, okay, G, green, B, indigo, blue, indigo, and violet. Anyway, so then that makes up the whole rainbow of the spectrums there. And so that is the very smallest part that we see. Most of the light that we see is either the waves that you see, okay, like if you had a red light bulb in something and then you shined it on a white t-shirt, what does it look like? It looks like a red t-shirt. Okay, it's because the waves are being shined upon it. Okay, what if you had something else? Now we're talking about what type of light is being reflected off of this. Okay, and so the different colors reflect different kinds of light, and that's for another lesson too. But most of the light that we see is either the light that's coming out a certain color or else what is being reflected off. And that all occurs in this small little part of the whole spectrum. Notice that this is from 400 nanometers to 700 nanometers. So when we're talking about that, this has a much bigger wavelength than this side does. In fact, when you look at the whole electromagnetic spectrum, the spectrum means it's a combination of all of them. We are talking about large waves over here. These ones are very large. Then we start getting into smaller waves, and these smaller waves now, we're talking about AM radio. I don't even know if most of you guys at your age even know what that is, but there's other radio waves too that are in here. Think about using your walkie-talkies. I mean, this is all in that area. Then there's FM radio. Some of you guys I know listen to FM radio. Okay, then we start talking about microwaves. And somewhere in here is probably where that 5G range is probably at too. Okay, microwave towers, they are the towers that our cell phones go with. And then we're talking about infrared. Infra means below. So this is below red. It means below red. And this is where our heat area is. In fact, all this area in here contains heat. Okay, and then we start cranking up the frequency, we start cranking up the energy, and now our wavelengths, they get smaller and smaller as we get a higher frequency as we keep going. Now, light doesn't penetrate through skin, does it? But UV rays do. There's three different types here, A, B, and C, and now we're starting to talk about ones that actually go into our skin cells and damage them. And you know that X-rays can even penetrate further into the skin, further penetrate into different tissues, and then gamma rays can actually keep on going further and further into and penetrate, some even go through the earth. Okay, so now think about this for a second. We've got some waves going on here. Okay, you know that this is low frequency, it's slow. High frequency. Okay, high frequency penetrates, it's got more energy. Okay, and I advise you, go ahead and find an electromagnetic spectrum. Most of them have them kind of flipped around, but I'm teaching it the way I learned it. So this is the highest frequency here, lowest frequency onto the right. And so watch out. I mean, if you've got a way to print it up, that's fine. If not, go ahead and take some notes on this. You do not need to memorize this. Okay, you wouldn't even if we didn't have the COVID-19 thing going on. I just expect you to understand what's happening here. That we're talking about really long wavelengths over here, and then they get so tiny. So tiny. They are, I mean, even when you talk about the visible light spectrum, this is the billionth of a meter, and so it is very small. Over here, some of these are as large as a building. Okay, and so when you're talking about the wavelength, now it gets smaller as you go to the left. Also, we are increasing our frequency because the waves are coming at a faster amount per second. So that's hertz. Okay. So, what are some of the big takeaways? The visible light spectrum is one small area in here. Above the visible light spectrum is UV. I expect you know ultra. Ultra means above. Okay, above violet. Infra means below, and that is below red. So that's some of the basis of it. Then we got the long wavelengths, low frequency. Okay, then we come up here. We're talking high frequency, high energy, and a very small, tiny wavelength. Okay. Now, also think about this, that a lot of these wavelengths come from different sources, some of them from the sun, and so think of it that way too. Now, I thought that this is a really nice picture. It shows the different sizes of the wavelengths. Okay, they're talking about huge wavelengths here. Okay, skyscrapers, that's further on down here. Anyway, then we talk about AM and FM radio. Cell phones are within some of this area here too, but I think that the 5G is within here. I've got to look up more information on that, but I think that that's still it's in a different area than what they typically are at now. Okay, then we're talking about microwaves and infrared. We're talking about heat in this area. Okay, microwaves probably up here too. And then we talk about the visible light spectrum. How small are those wavelengths? They're the size of bacteria. Okay, now they get really small when we're talking about ultraviolet, size of viruses, atomic size, nucleus size. So you're talking about really tiny wavelengths because it's got a very high frequency. And it just so happens that the energy keeps on going up and up and up as you keep going into higher frequency. Okay. Now, so where are some places that we, well, how do we make light? Okay, the old-fashioned one that was developed by Edison, it was a light bulb that had a screw top on it, and so it was created that way. He had troubles making it so that this filament that was inside of here didn't burn, and so he couldn't put air inside there. I always learned that it was created a vacuum, but I've heard that there's also inert gases inside of these too. But tungsten was one, so that when you put the electricity through the bulb, okay, it went through here and it had so much resistance that it caused it to glow because there's so much friction that the electrons going through there is creating friction, it's creating heat, it's creating light. And most of this right here created heat. And if you go and plug in an incandescent light bulb and you can't touch it, it'll get too hot. If you plug in some of these others, they don't get too hot. I mean, some of these still do, but think about this for a second. This right here's got mercury gases inside of it, and so it's got white phosphorus powder on the inside of it. And so once this mercury starts heating up, then it actually makes the phosphorus glow, and so that creates this fluorescent color. If they had clear fluorescent tubes, it wouldn't work too well. And then there's the LED lights. When I went off to college, my professors told me that this kind of light bulb right here is going to be the new thing. We worked with a whole bunch of these ones and white ones in labs. And the electricity can only go through one way. Otherwise, they don't work. They won't make any light. And they only burn at one frequency. So there's been a lot of changes. A lot of changes have occurred since I've been in college and learned about them. And so they create something that now it's pretty interesting because they can put in different LEDs, light emitting diodes inside of these, and they can make them burn at different colors. So like there's soft white, and then there's cold light. So you can buy bulbs at different types of wavelengths that are emitted, or frequencies that are emitted from them. Anyway, let's talk here for a second what some things that you should have gotten out of this video. You should have gotten that the wavelengths are created by magnetic and also electric fields are put together to make an electromagnetic wave. That it creates that there's a whole spectrum of different types of wavelengths. Only one small spectrum that we can actually see. Okay, and you should also understand how the frequency changes and how the energy changes, plus also how the wavelength changes as you go left to right on the spectrum here. And also you should understand light emitting diodes, that they only go in one direction, and that they are more popular now because they use less energy, just like the fluorescents use less energy, especially compared to the incandescent light. And that's all for now. I'll see you later.